No, I'm going to go in and just say, I mean, yeah, and that's, I'll probably, I don't know. Yeah, or like Caleb said, just walk and say, I hate people. Which isn't really untrue. Oh, look at hysterical. I just FaceTime you guys. Hey guys, we're learning about log cosines today. While I'm sitting there in the jury room, the people around me go, what is this dude doing? Get him out of here. Anyway, law signs. Law signs is for when you use law signs for non-right triangles. Okay, there is. Yeah, log cosines. With log cosines, it's just a little bit weirder. It's straight formula stuff, but you only have to use log cosines once, and then all of a sudden log signs will work. Yeah, ish. So law of signs, if you recall, is for when you are working with non-right triangles, and there's always one little rule for using them. You use law of signs, and you use law of signs. So if we label this out A, B, C. If vertices have capital letters, the sides opposite then have, very good. So angle A looks at little a, little b, little c. And what happens here is you get this ratio. You get the three ratios of the sides versus their angles. And we say that the sine of angle A is to little a, sine of angle B is to little b, which is the sine of angle C to little c. And depending upon what information you have, you can use, you basically are always going to be using two out of those three ratios, whether it's A and C, B and C, C and B, whatever. And then you just wind up doing a whole bunch of cross multiplying and solving. It is pretty sweet. Now, in order to use law of signs, the only rule is you have to have an angle and a side opposite. If you have an angle and a side opposite, that's when you use law of signs. If you don't, then obviously we'll talk about law of cosines, and maybe we'll talk about that Monday or Tuesday, who knows, whatever. My luck, I'll get stuck on a trial that takes 3 weeks.
That'd be terrible. I will teach. Give me lessons.
So when we're using this, sometimes you'll see law of signs all flipped, like little a over the sine of A, little b over the sine of b. It's more common to write it with the angles on top and the sides on the bottom. It's not a big deal. Either way works. Okay? A couple quick things about law of signs. When you guys have used these in the past, every time that you have used law of signs, it's always worked. It doesn't always work. Okay? There's a little couple things that happen here. We'll get to that here in a second. When you are working with law of signs, we'll come back to this. I need to go through all that here. Oops, how did this stop? I saved the wrong file. Sorry. There's a couple of different cases of the law of signs. And what I mean by that is we're going to have cases like angle, angle, side, side, angle, side, 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 angle, things like that. So we're going to have specific types of scenarios. A lot of these things are going to stem from having a solve ABC with angle C, blah, 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 and so on and so on and so on. Which means more often than not, you're going to be drawing pictures. Again, it doesn't have to be perfect. This is not to scale. This is just visual representation of what something's going to look like. So, we draw. Triangle, label, angle C, 103, angle B, 28, little b, 26. Which tells me that I have to find angle A, little a, and little c. With law of signs, or here in a little while, or next week, whenever we get to it, law of cosines, it's generally three things you're going to be trying to find. Now, in this case, what angle and what side do you have opposite? B. So what we use is that anytime that we have the angle and the side opposite, what I like to do here is I usually like to just kind of circle what I'm working with, and I'm going to use that as my pivot. What I mean by that is I'm going to use that given information to both solve for the side C and then solve for side A without reusing whatever other stuff I find. So here's what that looks like. I say that the sine of 28 is to 26 as the sine of 103 is to little c. Remember, sine of 28, sine of 103 are just really crappy decimals. Don't round anything. Don't just put 2 decimal places down and use those throughout. What I want you guys to do is to solve for c, and then type everything in your calculator like that. Bless you. Now, when you have fraction equal fraction, that usually means you're going to have a lot of cross multiplying. Are you okay with that? So if I move this around, I'm going to get c times the sine of 28 is 26 sine of 103, and then I divide by the sine of 28. So I know that c will equal 26 sine 103 over sine 28. And I leave my answer like that for right now until then I press my buttons. I want to show what I'm about to do before I do it. And remember, the big reason that I always say to do that is because if you accidentally hit the wrong digit and I don't know where it started from, I don't know what in the world you were doing. Okay? And that's the idea. So let's see, if I make a fraction bar, alpha y equals 26 sine 103 over sine 28. 5396. Everybody agree with me on that? I don't know. You could do that because then you could use the A to get to the little a. We gotta find them anyway. You could have gone in any sequence. It doesn't matter. It really doesn't. It will matter in a little while, but it's very easy to know what I'm talking about. So don't worry. Okay. So I'm getting little c at 53.96. We all right with that? Now I go to the next step. Good morning! What's the sine of 30? I did. Huh? Wait. What is it? Sine of 30?
Quick, pull out your phone.
No, you know what? What's all right? Which one of these angles is the 30-degree angle? Two? Yeah, it is. TWO. Over what? One half. Yeah, you're halfway there. Anyway, so now I found C. How many degrees are in a triangle? 180. So I take 180, subtract out the 103, subtract out the 28. Bless you. And I get angle A at 49. Then I just reuse the sine of 28 over 26 is sine of 49 over A. Now, one of the things you'll start to recognize is that when you have already solved an equation with the variable in the same location, why not just jump to what you've already done? You know, you knew you had to multiply by 26 and divide by sine 28. You'll start to pick up on that. If not, no big deal. It only takes an extra step. So, you know, 26 sine. Okay, just by moving it around. 26 sine 49, sine 28, 4180. 4180, are we okay with that? 41.8.8? And honestly, when you get to law of sine stuff, you kind of have to take a little bit of a grain of, take it with a grain of salt your results, because there's no way to completely verify that you are correct, like you can with Pythagorean theorem. In this case, really the only thing you can do is check, does the biggest angle have the longest side length, the shortest side length, the smallest angle, and so on and so on. And if that generally works, you're okay, right? And then go from there. Remember, make sure you don't just round before you get to the end. Try to hold off on rounding to the very, very end. Not terrible? Yeah, we did a little bit of it last year. Same deal. No thanks, trying to quit. So if angle B is 105, little b is 11, little a is 5. Gentlemen, went away. Not trying to scale. Remember, I'm just doing a quick visual. It doesn't. All I'm doing is drawing a triangle. It does not have to look right or like non-right. Shut up, Becky. What angle is it forcing you to find first? A, and that's the idea. A lot of times, as soon as you start drawing it out, it forces you to know which one you're looking at. So I'm going to use this angle B and side B to solve for A. Then I'll subtract from 180 to get C. And then I'll use angle B, side B to find side C. It's just it's same procedural, if you will. So let's see, sine 105 is to 11, as the sine of A is to 5. Everybody okay knowing that you have to multiply by 5 to get rid of that, move it over? So here's what happens. You get to this point here, you have 5 times the sine of 105 divided by 11 equals the sine of A. How do we get A by itself again? What buttons are we going to have to press? The inverse, yeah, the sine negative 1. Now, here's the way that I would do this. In my calculator, I would type in, right, it's not right. Don't have it open. Yes, I do. What's that? So let's see here. If I do alpha y equals 5 sine 105. And then over 11, hit enter. That decimal equals the sine of A. Remember how to use the answer button? Second sine of your answer. That way you don't have to round things through. You can do that too. Yep. So that gives me angle A at 2604. Are we all right with those shortcuts like that? 2604. And then so that means I'll have 180 minus 131.04. 48.96. So nice it's twice. Double 48. And then I'll use law signs one more time to get shot Mackie.
Why is there a hole on your face?
I'm trying to show you that I can draw things nicely. I know, not really. So let's see, 11 sine 48.96 divided by sine 105. Uh, 859. Okay, 8.59. And once again, I look at it and say, hey, do those sides and stuff match up okay? Yes. Indubitably. You gotta say it better. Inconceivable. Okay. As I'm taking a drink of hot coffee, you're like, big farm boy. See, the rest of your daily has got to be awful. You go back to Huntley and the teacher's fight is boring. Sorry that she walks really fast.
That's impressive.
She's got a motorcycle. Oh yeah, motorcycle. So we've talked about motorcycles in here a lot. I have, and this is one of the things that kind of irks me with you guys. Yes, a lot of stuff I say is BS, but you never listen to me.
What?
Exactly. And I'm trying to, I know, true, but I'm trying to be all encompassing. And I try to not influence, but I try to bring things up in conversation to make it look like it's still normal. It's just life. We can all learn. We can also enjoy time together. Or with the answer the entire time.
No, he has a. What is that? That's a bear. I've never heard that before.
On my computer. The answer was right there. Even people that have seen me on my motorcycle didn't get it.
That's really
No, I don't have a little flag on the back. What do you do? It won't work.
No, I
big angle? 140, which means every other angle has to be smaller than it, doesn't it? So if I have a side being 5, the other side can't be 7. It would have to be smaller than 5. See, you were wrong. Because if you got angle C being 64, all of a sudden you're at 204 degrees, and then we got to angle B. Does that mean angle B is a negative angle?
Yes.
So there are times when you are working with law of sines that you will come across a quick scenario and that you get two sides and an angle. Now, in geometry, when we had two sides and an angle, we always said that there was no in math, right? There is no. Let's say you can say it's just a free time to say the word ass. Ass. See, it's good. There's no ass in math, right? We said this. We said this a lot. Remember we did this side. And you're like, why is there any ass? And then we said that. I'm not lying. You go to my geometry class. I'm not. You said ass. What's that? Oh yeah, you're right. Oh. We'll have to remind you of that. Anyway, but sometimes when the ass shows up, it would have been great if you would have walked in right about that, but that's okay. See, it's better today. Why did you draw us? So I'm making up for it. Anyway, so a lot of times when you get to this idea when you have two sides and an angle, sometimes things don't work. I don't want to get into what we call the ambiguous case today because there's no way I can go through and show all of that. But one of the other things I do want to show you guys real quick with the law of sine stuff. One of the things that you can do with law of sines, or using law of sines, or using the scenarios and stuff like that, is if you ever get a side angle side scenario, you can find the area of the triangle. If you have a side angle side scenario, excuse me. If you have side angle side, remember what that means? Two sides, side angle side. If you have two sides and the included angle. So anytime you have two sides, so if you have this angle and these two sides, you don't have to do the same. You can use the formula of 1/2 side. What happens then is you take 1/2 side times side times angle, and that gives you your area. If you have side angle side, now we don't worry about all these different versions of it. Whenever you have side angle side, the area of a triangle will always be 1/2 side times side times the angle. Sine of the angle. Sorry, I read the word sine. Yeah, if you have side angle side, if you have a side angle side scenario, if you have a side angle side scenario, and I'll draw an example here in a second. If you have side angle side, is that side angle side? Yeah. So if you have side angle side, the area of that triangle is 1/2 3 times 5 times the This is a great shortcut that you will see for non-right triangles. This is one of the nicest shortcuts you will ever learn for finding areas. Okay. All right, so all you have to do is type in 0.5 times 3 times 5 sine 55, hit enter. I'm getting 6.14. Something's right. What's that? Oh. Gotcha. Square root of pi. Nerd. Now, the textbook, like I said, the textbook goes into all the different ways of writing it out. Don't ever learn it that way. Side angle side. 1/2 side side sine angle. That's all you gotta worry about. It works. You can, if you don't have a side angle side scenario, you can create a side angle side scenario by using law of sines to find a missing angle and then get the area real quick. It's a nice formula to learn. Next week there's another one that's really, really weird that also comes up from time to time called Heron's formula. It's another one of those things that just kind of terrible. So let's see here. Let's do those. All right. Let's just do those. I wanted to try to get to what we call the ambiguous case, but I just don't have time because I got sidetracked with the pictures and stories. We'll get into these next week. Hopefully, if worse comes to worse, what I'll wind up doing is I'll make a video lesson for you guys on Monday about the ambiguous case. Explain how you go about working with it. It is procedural. It is a very quick thing. Do you guys remember what a supplementary means? No. It works. What is supplementary? What are supplementary angles? Add to 180. Okay. So that's kind of the one thing we checked with on that. It's not too terrible. Okay. I gotta put the PDF on before people yell at me. You know, if I only had a fax machine. You have a fax number. I think the copier down in the main office does faxes. It's been a while.